Now that you've got prisms under your belt, it's time to tackle surface area of cylinders. And the good news is cylinders are really simple because you know prisms. Let's see how they compare. A 3D figure with two circular bases. So a cylinder is like a prism in that it has two bases. And those bases are both congruent and parallel. The lateral surface, though, instead of being made up of several different surfaces, is one curved surface like a tube. And just like in a prism, this distance here between these bases, that's the height of the cylinder. Sometimes you see it connecting down through the middle. If I could draw a straight line, you'd see it there. So what similarities and differences do we find in prisms and cylinders? I think it's good to look at these. First of all, we know a prism has two bases that are polygons, while a cylinder has those same bases, but they're circles. The good news is they both have two bases, and that connecting distance between those bases is still the height. Also, when it comes to the lateral surfaces, a prism has many lateral faces, depending on how many walls there are. But a cylinder is different because it only has one lateral surface, that curved surface or tube. But, like I'm calling them, both of them could be considered tubes for that lateral surface, which makes the formula easy to find when we unwrap it and make that rectangle. So, the good news is that because they both share all these features, the two bases, the height being the distance between them, and the lateral surfaces making a tube, they use exactly the same formulas. So that means we don't have to reinvent the wheel when we do cylinders. We can apply what we know to prisms. All right, so let's do it. We've got the lateral area from what we learned about prisms is that it's equal to the perimeter around times the height of the prism. So for a cylinder, this is the height. And there's a pretty significant difference. When we do this distance around, that's not called the perimeter. What's that distance called? That's called the circumference. So instead of perimeter, we're going to use circumference in its place. And if you remember the formula for circumference, it's 2 pi times the radius. And the radius, of course, would be the distance from the center out. All right, so that's circumference. Now, remember we have to times by the height to get the full lateral area. So 2 pi r h is our lateral area formula. For surface area, you'll remember it was the lateral area plus two base areas. Now, when you see formulas, sometimes you'll see it written that way, but more often you'll see it written in terms of the radius. So the lateral area we can just bring down from above. That's 2 pi r times the height of the cylinder. Then when we add in the base areas, remember, the bases are circles, so the area of a circle formula is pi r squared. And so for base area, we would put in pi r squared. And this is generally the formula that you'll see on formula sheets and such for the surface area of a cylinder. Let's try it with an example. We're going to find the lateral and the surface area of this cylinder. Now the steps are not as involved because it's a nice circle. We'll just go straight to our formulas. For lateral area, let's find 2 pi times the radius times the height. So bring down the 2 pi and let's plug in the radius and height. From the picture we can see the radius is here, it's 2 centimeters, and the height is this 5 centimeter distance between those two circles. So calculating that out, we get 20 pi. And I'm going to leave it just like that because they said give the exact answer rather than go into a decimal. 20 pi square centimeters would be the lateral area or the tube of that cylinder. Now when it comes to surface area, my formula is 2 pi RH plus 2 pi r squared. But keep in mind, guys, this is the lateral area. We just figured that out, so I'm not going to redo that. I'm just going to bring down my 20 pi from up above. And then let's finish off the formula getting the two base areas. Plugging in 2 as our radius will square it. Okay, so I'm bringing down my 20 pi. And 2 squared, that's 4. We're going to double that to make it 8, so we get 8 pi. 20 pi plus 8 pi is going to be a total of 28 pi. Slap on that unit and we're done. I love cylinders. They're cake compared to prisms. And some of them really are cake. I'm funny. So let's hit it with one last example. We're going to figure out the total cost that it takes to make 12 of these cans. If it costs us, look here, 0.02 cents per square centimeter. What's the aluminum needed? So we need to get the total surface area of the cylinder. or the can in this case. Let's jot down our formula. 2 pi RH plus 2 pi R squareds from the bases. And let's just go and plug these numbers in. That's the beauty of cylinders, is we can just plug in our numbers straight from the formula without a lot of extra work to figure out bases. So let's start with the radius spot. Now remember, that's just half this diameter they gave us, so we'll use 3 for the radius. The height's sitting right here, that's the 11, distance between those two circles, and then our radius again over here for the 3. So on our quick calculation, multiplying all those together, let's just leave it in terms of pi for now. 66 pi, and then over here we're going to get 9 times 2 is going to be 18 pi. So they're both in terms of pi. Let's combine them to one term of 84 pi. 84 pi square centimeters. And then I think it'll be smart to get that as a decimal. So into the calculator we go, and that is 263.9 approximately square centimeters. Now that's for one can. We're getting a pack of 12 cans, so let's multiply that by 12 for the total surface area in the pack. And we've got 3,166.7 if we want to keep rounding. I don't know how far we want to round that. And then that's the whole pack, but each of those, that's still square centimeters, and each of those costs us 0.02 cents. So let's now multiply this by 0.02 cents for each one. Okay, so it's 63.3, not dollars, this is cents here. So 63.3 cents for that whole 12 pack of cans, not including the soda in them. And those are the cylinders, so roll with it.